Okay, having discussed the Kw of water and talked about how some salts can behave as acids if they contain the conjugate of a weak acid or a weak base, we can now tackle finding the equilibrium constant for that conjugate weak acid or weak base. So let's just give ourselves an example to talk about. We'll talk about NH4Cl, and if we put that in water, it would dissolve into NH4 plus and Cl minus. This is the conjugate of HCl, which is strong, so I don't care about it. This is the conjugate of NH3, which is weak, so this is our species of interest. This is the one that can engage in the reverse reaction, so NH4 plus can react with water to produce NH3 and H3O plus. But if we have this, what's the K expression for this? So this is an acid, so it would be a Ka, but we also add a special little thing here to represent the fact that it is it's a naturally reversed process, or that we're dealing with the conjugate of something. So we put a star up here. To get this, what I'm going to do is I'm going to imagine both the reverse reaction, but I'm also going to imagine the natural forward reaction. NH3 plus H2O goes to NH4 plus and OH minus. So that's the normal forward reaction for this weak base. And what I'm going to do is I'm going to take the K expressions for both of these and I'm going to multiply them together. So the K expression for the acid that's happening in reverse is going to be NH3 H3O plus over NH4 plus. And the Kb for the normal forwards process, note there's no star here because it's the normal forward process, is NH4 plus OH minus, and what am I looking at here? NH3. Now let's look at what happens if we multiply those two things together. Ka times Kb. I'm going to get NH3, H3O plus over NH4. And I'm going to get NH4 plus and OH minus and NH3 on the bottom. What I'm going to notice I can do here is I have NH3 on the top and NH3 on the bottom and NH4 and NH4. And you'll notice that then all I'm left with is H3O plus and OH minus. Well, I can recognize that. That's the normal K expression for water. So this is actually equal to Kw, or 1 times 10 to the negative 14. So I can relate the equilibrium constant from the reverse reaction of a conjugate of a weak base to the normal equilibrium constant for that base to determine what the K expression would be using this equation right here. We're going to do that in the next example here. We're going to calculate the pH of an acid salt. So I'm just going to leave that alone right now, and I'll come back to that and show you what that calculation looks like in the next video.